In these lessons, your students are going to apply their experience with encoding information. They will start to build more complicated protocols to represent images in binary. Students will start with black and white images and develop their own protocols to communicate all the necessary data found in a black and white image. And next, students will make their protocols more robust so they can deal with encoding color images. These lessons explore the overlap between the CS principles' big ideas of abstraction, data, and creativity. We will use a tool called the pixelation widget so students can apply and test out a protocol for encoding images. You can learn more about that widget and how it works in the tutorial videos found in the CSP Unit 1 course on Code Studio. Digital images are stored in a computer as a series of pixel data, which encodes how much light and what color should be used at various points in the image. When the computer displays the image on a screen, it uses that data to set the color and brightness of the tiny lights on screen, which we then see as an image. The light levels captured in the pixel data change depending on the color, with the most basic color channels being 0 and 1 for black and white, and with the light levels getting more sophisticated as you add color. The protocols that students develop will need to convey the pixel color data as well as the size of the image. As the images start to include color, your students might want to use hexadecimal representations of their color values. You'll also learn more about hex in the tutorial videos found in the CSP Unit 1 course on Code Studio. When using the pixelation widget, your students will need to keep in mind how they're encoding the dimensions of the image, as well as the data for the pixels. Since the pixel data is the piece that changes the colors in the image, students are likely to get pretty caught up adjusting them. Don't forget that in order to get the image to look the way it's intended, all of the bits will need to be encoded properly. This means that changing the way colors are represented might require updating a significant amount of data in order for the image to look just right. It's natural for your students to experiment while using the widgets, and this is encouraged. By playing around with different color representations, students will build context and understanding around the numeric values of colors. And while your students are experimenting with the widget, it's important to ask questions to help them uncover the core concepts behind what they're seeing. Consider asking students questions like, why does the image look weird when you change the bits per pixel without also updating the pixel information? Or, how are black and white images different than color images? How does the order that you put the image data into the pixelation widget matter? What happens when you switch the color data with the size data? Reference your walk-around card for the pixelation widget for more questions to ask and things to look out for while using the tool.